Hi everyone, we are back with APIM Hotrod, and today I'm here with Alex. Unfortunately, Stefan cannot make our call today. He has a last minute problem, so everything's fine, no worries. So let's start with Alex. Alex, how are you? Would you mind to introduce yourself a little bit?
Hello, everyone. Pleasure to be here. Um, I'm Alexandre Vieira. I'm part of an organization at Microsoft we call the Global Black Belt. As this fancy name, but in reality, we work with customers, with strategic customers, and we work very close with engineering, so that we can then take the feedback that we learn from those customers into engineering to close the feedback loop, so that our products can improve over time. And has been really fun doing this, especially now that we have this AI momentum. So I've been very busy lately.
Yeah, sounds a very great job, let me say, right?
Yeah, it is fun, challenging, always tons of new things to learn. If you go into vacations and you come back, you have like so many new things to learn that it's really hard to keep the pace.
I understand. I understand. So great. So today we will talk about a topic that I really like a lot recently. And I explore thanks to your work, Alex. It's the AI gateway pattern with Azure API management. So would you like to tell us something more about it? Just gonna bring in a screen.
Yeah. So there's a lot of going on here because of this AI momentum. So as we all know, there's a big trend in the industry to adopt AI. We can see that in terms of what this means for the apps that we use. It's a little bit, and I guess that in this integration space was a little bit like when mobile apps were introduced. So you remember a lot of apps were need to be redesigned just to work on a mobile phone, and that in fact push a lot for the API management pattern. Okay, because suddenly you need to expose the APIs into the public so that they can be accessed through a mobile app. And now, with the introduction of generative AI, we are seeing a little bit of the same. Okay, so the intelligent apps needs to be redesigned, infused with AI, and of course, they need to consume different AI services. And to consume effectively these AI services, we see the need to have something in the middle to mediate, to do the job of ensuring security, load balancing, observability, a lot of different cross-cutting concerns. And API management as a concept is a good piece to hold these different cross-cutting concerns, putting API management here in the center, doing all of that. So that's where we see this AI gateway pattern, taking a lot of interest. Of course, Microsoft is doing some work here, but not only Microsoft. I will say that the entire industry is realizing this and doing some interesting work in this field.
That's great. That's great. Yes. And let's say the first question here is like that it comes to my mind. So we are bringing those AI kind of functionality into API management. And one question might be, okay, so why, so suppose token validation or token count and this kind of thing. So why put it in API management and not, there are already this kind of features on some libraries, right? So why centralize and not use those functionalities into the different libraries if it's already there in those libraries?
Yeah. So that's a great question. So we could, of course, put some of that responsibility indirectly into the intelligent apps. But what we see is that when we develop the intelligent apps, first, sometimes we use some kind of low code, no code kind of platforms that has some limitations on the capabilities that you do. Generally, they are really easy to do, but they don't have like full flexibility. That's one. And then you want to ensure standardization in some of the ways that you consume the AI services, especially around security is paramount in these kind of things. If you compromise security, you might compromise, the entire initiative, the entire project. So having that in a standard way, in a centralized way that is controlled by, by a specific team, is what we see as most successful within the enterprise. Okay, if you try to push this into the intelligent apps and the way that they are developed, of course, it's an approach as well, but we see that very difficult to happen. You have like frameworks for Python, JavaScript, Java, .NET, so many different languages with so many different behaviors is different to work in that level. So the vision here is to push for the API layer, and since all the AI services they expose APIs, okay, that's the relevance of an API management piece. Is that it's handling well APIs, nothing new, okay. It was doing that for a lot of years already, and AI services take advantage of that. Most of the AI services they have like an open API specification, and when you expose that through a component like Azure API management, then you can leverage the capabilities of this component to do all sorts of things. Okay, so that then you can have like very good control about the usage of the AI services. You can ensure security. You can have like very good observability to understand what's going on in when using those services, and realizing that the API management product team at Microsoft, they built some new capabilities that they call the Gen AI features or capabilities within Azure API management to do the task easier for us. Okay, for some
And
of them, for example, to consume Azure OpenAI, that is the main focus, at least for now, for the team. They made some specific built-in capabilities for this service.
I know because I play a lot with your work. You did a great job, open source collected on GitHub to understand and play with these generative AI capabilities. Would you like to show us your work, which I find awesome because it's extremely easy to start and use. I think the easiest GitHub repository or easiest quick start I ever seen in my life. So if you want to tell us
Thank
more,
you.
I'm really excited.
Thank you. So it all started with me wanting to learn this, and realizing that to learn in this AI space, uh, I should lean in more into working with Python because, as we know, Python is being used a lot within AI projects. It's being used a lot by data scientists, and it's a very nice programming language for this. And so initially, I built this just for my internal discovery, my internal learning process. And then at a certain point, I thought that was something worth to share with the community. So I started to polish it and introduce this concept of labs that with different scenarios that we can add progressively more and more labs to explore this pattern with the more and different use cases. As we know, in this space, in the right side, in the AI services, innovation never stops. We see new capabilities, new AI services almost like every day. It's very hard to keep the pace. And what I try here is then to put labs together with API management in order to explore these concepts, in order to take advantage of that, and to provide very good instruments to build new intelligent apps. Okay, so all this is what it is here. All this is in this repo. Okay, it's an open source repo. It's available with this short URL, uh, apim/genai/labs. Okay, it's available here. And one of the main things here is the labs that I was explaining. We have a big set of labs already, and we are planning to add more over time. But I will highlight, besides the labs, also the some tools, okay, that I found that in some circumstances they are really helpful when we are exploring this AI gateway pattern. One of the tools is this AI gateway mock server, meaning that if you don't have an open AI API endpoint to test it out, you can just spin up this mock server and simulate the open AI behavior. Okay. For example, if you want to try something like load balancing or to try um, rate limits, these kind of things, sometimes it's hard to provoke the behavior to a real OpenAI endpoint. So with the mock server, you can program the way you want it. Sometimes we inject like a specific prompt, and when we send that specific prompt, the mock server will return a specific error code that we want to simulate in our scenario. So that's one tool that might be useful for some scenarios. Then within VS Code, we use the tracing tool as well. This might be useful for us to have the full tracing information from API management. As you know, the API management is very good at this. You have when you execute the API, it will say in each step which policy it was executed, what it was done during that execution, so that you can trace effectively. And then another tool is the streaming. So with OpenAI endpoints, we can use server-side events so that the response will come in chunks, not in as the entire response. It will be like a small pieces of information. They call it chunks, so that you can the first response really fast, and then it will keep coming. What we see the behavior in a chat conversation, like for example in every Copilot or in ChatGPT, they are using streaming, and streaming represents some limitations when we are using with this kind of pattern. Some policies work with streaming, some others doesn't work. So when you enable streaming, there is some kind of a compromise situation, and you need again to experiment to find the right balance between enabling streaming and using the policies that you need for the job. So all these labs, they they are available in this repo, and to get started is really easy. We You can just clone the repo to your local environment. That's what I did here, and work with Visual Studio Code. I used here Visual Studio Code because it's great in a lot of different circumstances. We know that with VS Code, we have this great API management extension that allows to debug the policies, allows to test, allows to do a lot of different things. So it's VS Code. It's a great integrated environment to work with API management. Um, and we can run the VS Code inside GitHub code spaces as well. So if you prefer, you can go into the repo. That's another option. And you can go here and open a new code space. Okay, so basically you just create a code space and you'll run the code space, and you have a full development environment, but running on the cloud. Okay, very convenient for everyone doesn't have a local environment set it up. I have this local environment. I will just quick show some of the labs. Um, so one of the first labs is this, is to do load balancing. Okay, this is being asked a lot by different customers. Imagine that you have different OpenAI instances, maybe in different regions. Maybe one instance has like provision capacity, and you want to give priority to this instance over the others that might be pay as you go. And we want to have like a seamless load balancing. And if one of the instances fail, of course you need to offload to the other one that is healthy. Luckily, the team did a great job here and put like the concept of backend that we had already in API management, but extended to with two new capabilities. One is the circuit breaker capability, that detects if the backend breaks and it will make it unavailable. And the other one is the concept of backend pool. That is a specific backend that is a pool of backends, like it shows here in the picture. So from this lab, and the way that these labs are structured, is that they start to create the resources needed to simulate this with Bicep. So if you have nothing in your Azure subscription, you just click here on Run All, and basically will execute all the steps in sequence, in the right sequence, and in the end you will see the results. Okay, that's the convenient, just for you to try it out with the less effort possible.
And this is
And in the
wonderful, right? This
sorry.
is wonderful because this is why I was saying it's super fast to start, because you don't, you just press a button and all the steps are done. If you want to change something about the resource group name, you just go in your Jupyter notebook and it's 2 seconds, right? It's so
Exactly, yeah.
all lean and voila.
Yeah, exactly, yeah. And for my day-to-day job where I need to support, different customers with different scenarios, honestly, for me, this helps a lot. So, and if it helps me, most likely it will help others as well. It's good that it's based on Bicep, because then you can take part of the Bicep that is used here in the lab for your production scenario. So that, for example, I'm defining the backend pool with Bicep, and then you can take the snippet of Bicep and include in your existing infrastructure as code, and progress it to production. So if I click here on test the API with, in this case, with a direct HTTP call, this is using Python and might be scary for some of you that doesn't know Python. But if you look, it's really easy to understand this script. And as we can see here, we will use the gateway URL from API management. Okay, that's the URL that we will send. But we will send a request with the OpenAI format. Okay, what OpenAI is expecting. This is the typical prompt. So here I'm making fun with a sarcastic bot and sending the response. And if I hit play here, what I will start to see is the responses from the service. I can see exactly how much time it took, the status code, the header information. For everyone working with integration, we want to see the headers. And there is a nice header that says in which region the request was processed, okay, in each OpenAI instance. And we will see all the responses, and then in the end, we can see a chart with the results. Okay, this is useful whenever you want to to test if your load balancing configuration is according your needs. So I will hit play here. Uh, Jupyter notebooks are very good at this as well because it's very easy to build this kind of charts. And if we look in this chart, we can see that the configuration that we put it here initially. Let me just go over this really quick. So we said that OpenAI in UK South has the weights of 80%, in Sweden 10%, and in France 10% as well. So if we look at the chart, this is what we are getting. Like 80% of the requests were processed by UK South, then 10% by Sweden and France. So a simple way for you to make sure that your load balancing is working like as it should be.
Yeah. And it's lovely. So why I'm also not a Python guy, but this Jupyter notebook really help the full step in one click, but also you can understand how your lab is working by doing one step per time by just using a user interface and in Visual Studio Code and press click. So it's great. I play with a lot of them, and also because it's full open source, you can go and change something. You can add something on top of it to build up your use case starting from your lab.
Yeah.
I have one while you're explaining something. I have a little question. So I see these two kind of scenarios, and I would like to have your opinion. So one scenario is like mainly an enterprise company. I just want to create AI services, shared services, and offer to different intelligent app within my company. Okay. And in that case, in a classic AI API gateway or AI gateway, I will create this abstraction on top of it to offer those services in a, as you said, uniformed way. And then also, I was wondering your opinion. What about the other scenario, like those AI gateway are external, so provided by someone else, and I'm using API management to access to that external services. So internal kind of service, shared service versus external. What's your opinion on that? You see also both scenarios, a sort of proxies versus a reverse proxies kind of scenario.
Yeah, yeah. We have been seeing a lot of in this space, a lot of different kinds of integrations. That's why in these labs we have this big set of different patterns of integration. So we just see this back and pull load balancing scenario, but there are a lot of other scenarios as well. And sometimes in the back end, what will be consumed might be, instead of just an AI service, might be in a gateway for other services as well. Okay, but what I've seen as really powerful within every enterprise, in order to get really good control on how these services are being used, is that you need to have metrics. You need to understand who is using what. Okay, that's why one of the features that the team built is this token metrics emitting, that I will just quickly show here. That when the application, when the API management is configured with application insights, it's just going to send the metrics over to application insights. And for example, imagine that you have here 3 different intelligent apps, each one with their own subscription, with a subscription key from API management. And then you can have this kind of charts in application insights. You see here like subscription 1, subscription 2, etc., and understanding exactly how much usage was driven by each application. Okay, so that you have full control about who is using what. And that doesn't matter if here in the right side is OpenAI or another AI gateway or another service, doesn't matter. You have always full control about this usage.
And I love this just for I use I use your labs and I put it together just for the visit three of your labs. So this token emitting metrics, the RAG pattern, and the one of observability to just to see that was wonderful. So I have my client that calls first the embeddings and then it calls like the Azure search and then eventually the OpenAI, and then I can see I simulate different clients, so to see this kind of visibility that you gave to us from who is using what, but also within a single application, all the observability and this distributed tracing is it's really wonderful to govern and to keep under control the usage of those services, and really that's why I was so happy to have you on our show because I love so badly your work.
Yeah, thank you. Yes, in this kind of scenarios, for example, when you have this vector searching, that is this RAG pattern, that is very common pattern nowadays to build bots and have your own data here with the AI search. So you can index here entire databases, PDFs, whatever you want. So very easy to implement kind of pattern. And what I was seeing that just OpenAI API was putting with API management and having direct access to the AI search. But at a certain point, you want to have like full end-to-end traceability on what's going on. And the nice thing about API management is that when you send a request ID in the request, and then from different calls you send the same request ID, when you see the transaction in application insights, everything will be correlated. Okay, so in this sense, we have here different calls, uh, and in this lab, when we will see the end result, and I will click here just to show this, when we will see the end result in application insights, what they will show is this kind of end-to-end traceability. So we have the call for Azure Search. We have the call for OpenAI. We can see what was passed, how much time it took, etc. Okay.
Okay,
Let,
that's
let me
cool.
also highlight just a new policy that was just introduced. It's the Semantic Caching Lab. It's still in public preview, and it's really powerful because I will just show this chart. So after you configure the policy, you see that the first call could take some time, but then it will cache the the result, and then the other responses will be really quick. And as we know, user experience, it's mandatory to have like very good response time, and um, and with this we can have like very good latency, and all these responses didn't consume any token from AI services.
Yeah,
And
and
the cool thing
let's
about
yeah, sorry. Let's even if you are a little bit over time, no worries because this is interesting. So this
yeah,
policy is called semantic caching, right? So it's not a classic caching. My question here
exactly.
is like, what does the I mean, what are the difference from a normal caching? So it cache based on some deviation from the prompt, or what is the what is the difference?
Exactly, because we had caching in API management for a lot of time already, so it seems nothing new. But what's different here is that, and this is what this lab is exploring, we are sending different questions, different prompts here. Okay, they are different, and you can see that in terms of text, they are all different, but in terms of semantic meaning, they are the same. All the questions ask what is the current time. Uh, so the API management is using a feature from Redis Cache that does semantic searching and using embeddings. And with using these different text, it will understand that the semantic meaning is the same, so it will respond with the same answer in this situation. So, for example, in this case, we will see that the question that was response, it was always the same. In this case, it says always, but I'm a bit I'd love to help you. Blah, blah, blah. So we will see a consistent response every time, although the question was a different question. So yeah, it's not the cache that we had; it's a new cache to do
Okay.
this semantic searching.
That is clear. So you have 5 different questions, and you always end up with the same answer. So you are moving from 3 seconds for the first answer, for the first response, to 0.56, so less than 1 second with the semantic caching. That's
Yeah.
great. It's really great stuff you're showing to us. So we are a little bit, we are, let's say, at the end of our show. I'm sure that we could continue for a
Let
lot
me
of
just show
time.
you a last one. I will take
Yeah,
you
go
just
ahead.
1 minute. This was I prepared this
For me.
just for you. So, we have GPT-4o, the new model from OpenAI, real powerful model. And sometimes people don't know if it will work seamlessly with API management or not. So this is a little bit to experiment that as well. We have this GPT-4o inferencing lab. And the nice thing about this one is that we can use base 64 images and send it through the API, okay? And in this case, we are asking the model what's funny about this picture, okay? And we can run it, and it will do an interpretation of that picture, and hopefully it will understand why Italians don't like pineapple on pizza.
It's always a nice joke, pizza and pineapple. That's great. That's great. Okay, so Alex, thank you so much for this. As I was saying, your repo, your labs are very comprehensive. They are covering a lot of scenarios, and yeah, I advise everyone to go and check it out. I'm adding here on the screen one link to, you also showed before, another ak.ms, but this one is the one that I always use. Feel free to follow it.
That's good. Yeah.
Yeah, and explore it. Yeah, I'm still curious to see, yeah, all of these the merge of this AI gateway, and also then to see how under high load all the performances is also another thing that I'm very interested in. But that will be maybe for another episode. For today, again, I a big thank you to you, Alex, to join our episode, and thanks to everyone that will watch this show.
It
Okay,
was a pleasure, Massimo. I congratulations for the channel. I think it's really informative and helpful for everyone with a passion for API management and using Azure API management. And it was really good to be here with all of you.
thank you again. Thank you, Alex, and see you soon.
Bye bye.